Okay, so what are the westerlies? We talk about, oh, the westerlies. Well, and we know they're kind of the prevailing winds that go across our continent. But why? Why? Well, it's physics, actually. So you have the pressure gradient force, right? And the pressure gradient force essentially moves from the equator to the pole. So it wants to be pushed poleward. However, you have the Coriolis force, and that affects which way it's going to turn, right? Which way it spins, the earth spins, and so it's going to affect which way it turns. And so the wind, the westerly, is a result of the pressure gradient and the Coriolis force. And that's why we have the westerlies. Now, they're never straight across. Oh, shoot. They're never straight. If it was straight, then meteorology would be a lot easier. But no, we have to have these things called the Rossby waves, and there are about 4, 5, or 6 of them throughout the Earth. And you can see them here. They actually they're the cause of these little bumps. So the bigger these circles get, the more indented or prolonged these bumps get. Those are caused by Rossby waves. Now, here I kind of pointed out the boundary between the cold air and the warm air, the Rossby waves right here, right? And then there's this arrow thing with a thick line. That's the jet stream. Okay? The jet stream is basically just a stream of air that moves really fast. And they're part of the westerlies. And this stream of air is not just like a narrow little thing. It's pretty big. It can go from about 100 kilometers to 500 kilometers, which is about 60 to 300 miles across. Right? So that's fairly big. The wind speeds are large. Right? 100 to 400 kilometers per hour. Right? So that's about 60 to 240 miles per hour. Now we get 60 miles per hour. You know, that's the slow speed, right? And then you get 70 miles per hour. You might even get 80 miles per hour, right? Those are like highway speeds. Right? Well, then you get up to, hopefully you don't quite get 100, right? But you get up to 100, 150, 200, 240. Well, the average Nascar speed is 156 miles per hour. 156. So this is almost 100 miles per hour faster than that, at its top speed, of course. And there's actually 2 jet streams. There's polar and subtropical. We'll talk about both of those. But just to show you, I don't know if you've ever been to a Nascar race. I usually ask this question when I'm in class, hey, who has been? And I'm like the only person that raises their hand. I like NASCAR. Grew up watching NASCAR. I grew up in Detroit, Michigan, so of course we grew up watching cars. But here's NASCAR, and the wind caused by the car going 156 miles per hour. Just watch this lady. It's quite comical. Right, did you see that? It's worth a watch. And that's just 156 miles per hour, right? Alright, so let's look at the polar jet stream. It changes. See, you have the one in the summer, which is much, much further north, and then you have the one in the winter, which is much, much further south. Still not quite reaching us, but still much, much further south. And this goes along the polar front. Remember the polar front, where the cold air comes down from the poles? In the winter, it actually moves faster. You can see that in the diagram. So in summer, it's north and slow. In the winter, it's south and fast. See? I'm just thinking that It's not only the snowbirds that move south for the winter. There's also the subtropical jet, and that's down here. Oh, look at that. We're right in the way of it. Right? This is semi-permanent, which means that it's not there all year round. Right? It usually happens in the winter. And it starts at about 25 degrees north, 25 degrees south on both sides of the equator, and goes up a little bit higher, as you can tell, because we're in the 30s, and that's sitting there. And this one is much slower. Alright, so we know that the air kind of moves east to west, right? We've got the westerlies, and if you look in the southern, they've got the easterlies, or the east trade winds. And we also know that heat moves from the equator to the poles. So there's a constant, air is moving one way, and heat is moving the other way. And so that's where these Rossby waves develop. Because as the heat starts to transfer up, or the cold starts to fall down, you get these little waves.